Welcome. Thank you for joining us today for this talk on Microsoft Azure and TigerGraph, a powerful combination. I'm Victor Lee, Vice President of AI and Machine Learning at TigerGraph. I've been with the company for 8 years. I have a background in graph data mining, as well as several years in the tech industry. Joining me today is Timo Klimmer.
Hello, hi, my name is Timo Klimmer. I'm a cloud solutions architect specializing in AI and machine learning. I work at Microsoft since 13 years already. And during the last years, did quite a couple of interesting jobs. And now I'm coaching larger enterprises and startup using Azure. And I'm in Graph since almost more than 3 years.
Thanks, Timo. So for our agenda today, I'm going to start off and talk about why this combination and why TigerGraph. Then I'm going to hand it off to Timo, and he's going to talk more about the Azure platform. And then he will conclude with TigerGraph on Azure with some examples and demos. So anytime you're using TigerGraph, you've got it as a wonderful solution for scalable analytics of connected data. It's the top solution for large graphs and analyzing those graphs. But any full solution is going to call for more. You may be bringing your data in from somewhere, maybe in a data lake. You may want a front-end web solution. You may want additional AL, ML capabilities. Even though TigerGraph does come with some wonderful capabilities, you may have an existing AI infrastructure. You may have additional things. There's many other things offered within Azure to make a much more complete solution. So TigerGraph is essentially a data and analytics section, but a resource, data and analytics resource, but any full enterprise solution may call for more. And that's why the combination of TigerGraph and Azure is so important. So let me look at the key reasons why you might want to use a graph database and one like TigerGraph. First, it's going to give you richer, smarter data because it emphasizes the relationships between data. What are you doing when you're analyzing data? You're trying to correlate things, you're trying to see patterns. That's what graph does. It represents things like that. So you're able to break down your silos by connecting your different data and then start to gain that insight. You can ask deeper and more complex questions because you're able to form questions based on patterns of activity. You think about when you're trying to solve a mystery, you talk about connecting the dots, and that's what graphs do. And the connections here have semantic or meaning to humans. And with a platform like TigerGraph, it's very easy and performant to search both widely and deeply. You get performance through TigerGraph's massively parallel processing and distributed database. So your queries run fast, they run on big data. You can run graph algorithms or your own queries, and you get explainable results as we talked about those semantic patterns. So you're setting up questions that actually make sense and that even non-experts can look at the answers and understand whether it is the business leaders, whether they are auditors. People understand graph, and whether you are looking at it visually or just talking about the data model. And that is also one of its huge benefits. So it's so important that Gartner thinks that by 2025, 80% of large enterprises will be using graph. We've already seen significant growth in the past few years, so that 80% looks to be very realistic. What are some of the use cases? If you could get better insight into understanding the behavior of different things you're modeling, whether those are persons, products, processes, what could you do with that? Well, you're going to make better recommendations. By understanding things better, you're going to see similarities, you're going to be able to make better predictions, which is the basis for recommendation. You're going to be able to detect fraud better. Fraud is a huge problem, not only for financial institutions, but for retailers. We have significant, some of the largest banks in the US and in the world are using TigerGraph to help detect fraud, to improve the accuracy at which they can both detect real cases and realize when cases are not fraud and allow those transactions. Find similar customers, again, to recommend better cases of medical treatment, to group customers together for more targeted marketing. With that marketing, you get better ad targeting, and obviously something that looks like a graph, a supply chain. So, you have connecting things flowing from the raw resources down to the final product. And we've all understood how big a problem supply chain disruption can be. You need something where you can quickly analyze changing situations. If a chain in the links, if some link in your supply chain is broken, what do? You have to be able to reanalyze and come up with a new solution. A scalable graph database like TigerGraph can help you do that. As I've suggested, here are some of the things that make TigerGraph different from some of the other graph databases on the market. It's the ability to follow not just a few links, but many, many links in the graph, both in depth and in breadth. Because in order to find patterns, to search through the data, you have to be able to actually scan all the data and look for patterns in real time. And TigerGraph, due to its massively parallel processing and its distributed nature, compressed data storage, it is able to do that, handling both transactions and analytics. As I said, I talked about that scale. So it's performance with scale. You're able to connect all your data and analyze all that data. And you can both increase the storage, scale your storage as you need, and also scale the computation as you attempt more and more, whether you have more people doing computation, like multiple analysts or multiple customers, or whether you are doing larger tasks, more complicated algorithms, whether it's lots of activity or one big activity, you can do that with TigerGraph. And that gets into the built-in analytics, algorithms that run in database on the freshest data, because you're running directly in the database, not on some exported copy of the data. And increasingly, machine learning is getting blended directly into the database, and which will then also naturally connect with additional ML resources like you might find on Azure. Let me give you an example of a workflow for anti-fraud. So first, you have to assemble your graph data in stage one. You have the transactions, perhaps. You have users and their profiles. You can form what's called a customer 360 subgraph within your transactional graph. You can have information not only about people, but about accounts. If you are a retailer, you have information about the products and services. So you're bringing in data, both existing stored historical data, plus new live data from, say, ongoing transactions. You then, through a combination of maybe use case specific pattern searches or standard graph algorithms or graph embeddings, you analyze the graph data to extract features of interest. So that produces your enriched database. So not only do you have a graph, but you have a graph which tells you even more about the data that you're interested in. Stage 4, you do your analysis. You could be supervised machine learning, where you can do either in the graph or externally in the platform of your choice. You can also directly look at some of those features. Some of those queries might point out, you might draw conclusions directly from the queries, or you might want to train a model based on those features you now have. That's going to give you your model in stage 5, and then you can deploy that model on your real-time incoming transactions. Again, because of TigerGraph's performance, you can analyze transactions in sub-seconds to see whether they are fraudulent or not, based on the characteristics that your trained model told you to look for. Once you now have this model in place, you can give you a real-time result. And based, again, on your particular situation, you can either take action immediately, which may be to reject a transaction, or you may want to send it to an analyst for further investigation, and that's where visualization can be handy. So you have this multi-stage flow, but it's based on building the graph, extracting graph features through algorithms or queries, training a model, deploying the model, and taking action. And finally, just to give you an example of some of the graph features I'm talking about, here's an example of a phone call graph used to detect phone-based fraud. So each node is a phone, and each edge or connection is a phone call. And based on collecting the historical data of past phone calls, we can search for patterns, such as, is there a community of people that call each other frequently? That indicates some sort of established relationship, friendliness, probably not fraud among them. You look for also a loop, like did caller 1 call 2, call 11, call 3, who then called 1 again? Again, that establishes some familiarity, so fraud is less likely. So any of these certain types of patterned behavior, which then we could put, if you have some tagged data, you can then train a model, and we'll tell you which of these features may be indicative of sort of favorable good behavior, or conversely undesirable, unwanted call behavior. So this is just some of the ways that graph can lend itself to these explainable features. So to wrap up my talk about TigerGraph, it really offers a full spectrum of graph data science at scale. Allows you to connect all your data, allows you to query it using very SQL-like queries, but which are also able to implement complete little procedures, which then leads itself to writing algorithms. You can implement algorithms, and there we have an open source algorithm library which runs directly in the database. And that lastly leads us to learning from the data, machine learning. And that's with our latest innovations with the Graph Machine Learning Workbench, where you can, using Python notebooks and integration into Azure ML, you can run graph neural networks or other machine learning, extract graph features, run graph-based machine learning directly connected with your TigerGraph database, and all integrated within the Azure ML framework. So that's TigerGraph. And so now I'm going to hand it over to Timo to tell you more about Azure, and then how TigerGraph and Azure can work together.
Right, so what is Microsoft Azure now? As you can see on the slide, it's a very big cloud. So in fact, Azure is one of the hyperscale clouds that we have in the world. And there's a very comprehensive range of services that we have. So for example, there are services that provide infrastructure. There are services that help you to develop applications. There's also data and AI solutions, Internet of Things, even quantum computing, mixed reality. So that's all available in Microsoft Azure. Interestingly, we also have what we call the Azure Marketplace. So the Azure Marketplace is a place where our partners like TigerGraph can provide their own solutions, so that our customers can also make use of things and leverage things that others have done, which may be a better fit than the native cloud services that we have. To be very honest with you, it's extremely difficult to navigate through the jungle of all of the different services that we have. So meanwhile, we have more than 200 native cloud services. And then on top, we have all the uncountable services that come from the Azure Marketplace. So here's a hint that I have for you. If you're interested, just go to azure.microsoft.com/services, and then you will get a directory of all the native cloud services that we have in Azure. And if you are looking for marketplace solutions, which may be probably maybe a little bit higher than what we provide in our native cloud services, then go to the Azure Marketplace and just explore all the great things that we have there. What you see here on the slide is the Azure network. So as you can see, it's quite large and it's quite global. So we have more than 60 data centers around the world, which form Azure. So as you see, it looks very global, but in fact, and that's not something which is very known to many people, but we can go very local also with Azure. So you could also run your Azure in your on the premises if there's really the need to do that. We are also regularly tested against different compliance audits. So as you can see in the slide, we have more than 100 compliance offerings. And if there's the need to keep your data local in your country and so on, then that's no problem at all. We also can guarantee for countries that the data will stay within the country. If for whatever reason you cannot work with the internet, we also offer what we call ExpressRoute. Essentially, ExpressRoute is a dedicated line to Azure. So if you have very sensitive data, there's also a way to transmit the data to the Azure data center without using the internet. All right, but now let's go to something which is probably a bit more interesting. So when it comes to innovation, we are not that bad at Microsoft. So we have a couple of research centers spread across the world. And from time to time, we achieve really good breakthroughs. So as you can see on the slide, in 2016, we were already able to reach human parity with object recognition. So essentially, that means you give our AI a picture, and then it will tell you what you can see on the picture. Then in 2018, we have reached human parity with machine translation, which definitely also was a very good breakthrough. We're also very good at speech synthesis, and I will show you an example later. And one of the latest breakthroughs is around summarizing documents, and also vision captioning. So this can describe you what you can see on the image, but it's a bit more powerful than what we had achieved in 2016. So the good news about all the innovation that we have is that whatever, no matter what type of user you are, we make all this innovation available to you. So for example, if you are a business user, you might have heard about the Power Platform, which is a set of tools that enable business users to achieve great things. So maybe you have heard about Power BI already. You can use, for example, cognitive services in Power BI and then make use of all these things without knowing coding and so on. But also for the developers and data scientists, we have goodies. So as you can see in the slide, there's, for example, these cognitive and applied AI services. Essentially, that's a very large set of customizable, high-quality AI models that you can easily use to easily integrate into your applications. So if you have no idea how to, for example, do translation, then you could use one of these services, and then spice up your application with something that translates, for example, from English to German or whatever. As you can see on this slide, there's multiple categories. So we have a vision category. So as an example, if you wanted to apply some OCR to some documents that you have, our OCR service supports more than 164 languages. But there's also, for example, the custom vision service where you could easily, also using some browser interface, which is easy to understand also for people who are not that deep into machine learning. They could use the custom vision service, for example, to detect things in an image and so on. So that would be custom things. We're also quite strong in speech. So like all the popular things like speech to text translation is available, but also the other way around. So you could, if you have a good text, then you can also synthesize this into an interesting speech. Language is also very strong category. So for example, if you wanted to extract information from forms, if you want to classify the text, which as an example could be a ticket that you get at a help desk, or maybe you want to remove PII data. So that's all available, so you can easily do that. The point here is maybe you would be able to build your own models, but in many cases you just do not have the data, you do not have the expertise, maybe you also do not have the budget to all these things. So we have found in the past that this is very helpful for our customers because you just easily use those services. Essentially, there would be REST web services and then a couple of browser portals on top oftentimes, and then you can easily use that within a very short amount of time instead of building all the models on your own. Yeah, the decision category is also very interesting. So, for example, you have the personalizer, which would help you to take the right decisions and recommend the right things with regards to some metric that you want to optimize. And last thing would be OpenAI service. That's something that I will show you in a moment. But it's also very powerful, and I would say like the next gen of NLP. So there's a lot of stuff in there. Just in case if whatever we provide is not a good fit for you, we also offer a couple of services that will help you to build your own. For example, we have Azure Machine Learning, which helps you to build a managed pipeline to train your own models and so on. Okay, then let's go into a couple of demos so that you can see how this actually looks like. I will have to switch my screen and go to the browser. What you see here is the Form Recognizer Studio. So we have multiple studios for the applied AI services. So essentially a studio is about, it bundles a couple of services and offerings that you have around a certain topic. So the Form Recognizer Studio provides you services and capabilities to extract data from forms. We also have other things like a speech studio, where you could for example, train your own neural voice, or whether you can use a synthetic voice or pre-trained voice to create things and so on. There's also a language studio and also other studios. So as you see here, there's a couple of things. So you could use that just to simply run some OCR on the document. And there's also pre-built models. So if you wanted to analyze the contents of a receipt or of an invoice, and you could easily use the pre-built models. But we also have the opportunity to build your own custom models, which might come in many cases, I would say. So usually what you have in those studios, you have to create a project, and then you can train your own models there. So let me quickly open this project here. The idea here is that we want to extract data from a form. And so I've uploaded a couple of forms. So that's 5 forms now. In reality, you would probably need some more in the range of like 50 or something. So it's not that many, but it's a few. And what you then have to do is Azure then automatically extracts all the text that's contained on the document, and then you just have to click on the text, and then you can annotate that with different. You can give it different entity types. So, for example, in this case, if I would select merchant, then this would mean that this purchase would actually be a merchant, which obviously is not the case. So let's remove that. So what you see here is all of the content has been annotated. Yeah, so there's these red lines around the greens and so on. And on the right side, you can see here that different information has been extracted. And you have to do that with a couple of documents. And then once you have done that, then there's this train button on top right. And then you can train the model. Once you have trained the model, then you could open this model, and then you would see, for example, the accuracy for each of the different fields that you have selected. So I think in this case, it looks quite good, except for the signature. Signature does not work that well in this model here. But now, once I've decided that everything is good, then I could test my model. So I would click on test, and now in this case, I can just select another document that I've never shown the service before. So as you can see, that's a new purchase order. That's a new one. And now if I click on analyze, then it just runs the analysis process. And in a moment, it will show me all of the different contents of that form. So yeah, very easy things like dated as and so on. But it's also able to capture the content of tables. Yeah, so as you see, there's a couple of order items, and on the right side, we can also see contents of this table, this order items table in this case. So this is just one example. That's an example of the Form Recognizer Studio. And now let me go to the next demo that I have. What you see here is OpenAI. So as you might know, we are in collaboration with OpenAI, and we will soon offer the OpenAI service also to our Azure customers. And this is just a demo of what OpenAI can do already today. So what you see here is essentially you see text. Yeah, that's the text in this paragraph. And then I have a command for the model, which says summarize the fruits from the following text in a table with columns, fruit, color, and flavor. And now I can submit this. And once I've submitted this, then it will automatically create me a table with the name of the fruit. It gives me the color of the fruit. It gives me the flavor and so on. So I think this is very powerful because especially when you work with graph and knowledge graphs and so on, this is, I would say, like a very fast path, maybe also a shortcut to extracting relevant data from text. Because previously in the past you would build a lot of models on your own, and yeah, OpenAI can do a lot of work for you automatically within Snap, I would say. But it's not only about extracting text. You could also use the model to create text, actually. So let's go to this example. So in this example, I told it that it should write a creative advertising for a holiday resort, which is named the Blue Fish, and then I gave it a few terms. And actually, you're also able to do this in other languages. So I've tried this in German as well, so that worked also very good. But since this is an English session, I will only show this the English demo. So let's quickly click on submit. And now it's writing a creative app for me, and then I could use that text and add it to my system and use it from there. So for example, if I would need to write a lot of ads, then I could use this easily just using like 5 terms, and that's it. All right. So let's then go to the next demo. So unfortunately, I mean, it's fortunately, but in this case for the session, it's unfortunately, we have really a lot of services, and all of those are really cool. So you can do a lot of stuff. So I have to limit myself to the stuff that I'm showing. But let me quickly show you the speech studio also. So as I said already, we can use Azure Cognitive Services to synthesize speech. And just let me quickly show how it would sound like if I would give Azure the text that you see here on the screen.
Hi all, TigerGraph's Graph and AI Summit is so cool. I love to be part of the show.
What you probably see, or what you probably recognize, is the quality is extremely good. We use neural networks to provide the speech. We have a lot of speeches models pre-built and offer them out of the box. However, it's also possible to train your own model with your own speech. For example, if you would need something like that for a corporate identity or something, and then this would also be available using Azure. All right, now let's go back to the slide deck. So what I've shown to you was just like a very limited and small excerpt of services that we have in Azure. But just in case if there's a model that is not available and you probably would need to train a model on your own, then we provide, for example, the Azure Machine Learning service to you. So the purpose of Azure Machine Learning is to provide a machine learning platform to you. And as you can see on the slide, we try to cover all of the different audiences. So on the left side, there's the citizen data scientists. That's usually the ones that have very deep domain knowledge because they work in some business department, and they know exactly how things work in their domain, but it's very difficult for them to build a model. So you could use those people could use, for example, the Azure Machine Learning Designer and then visually create their own models. And then on the on the right-hand side, we also have the professional data scientists, and those are the ones who really prefer to code, use their special frameworks. They work a lot with solutions that come from GitHub and so on and so forth. And then in the middle, we have automated machine learning, which is sort of like beneficial for both of the audiences, citizen data scientists and professional data scientists. That is because usually a citizen data scientist doesn't really know too much about how to build a proper machine learning model. This automated machine learning feature also gives hints to the users. For example, it takes a look at the data, and then if the data is good and so on, then it would tell you that, and it would also give you guidance how to change that, which that the data is not good anymore. And also for the professional data scientist, AutoML is also very valuable because it takes a lot of it saves a lot of time because usually it takes indeed some time to build a model from scratch and so on. And if you use automated machine learning, then you have a very good baseline in a very short amount of time. All right, then let's go to the next one. This is now getting back to TigerGraph again. And now the question is, so let's assume you have decided for TigerGraph, and then you have decided that you want to use it on Azure, but then now the question is, what options are there actually? And as you can see on the slide already, there's two different things to distinguish. So one thing would be you use it in dev test, and the other thing would be you use it in staging and production. And obviously there's quite some differences. Let's go into dev test first. So obviously you could always use just a plain Azure virtual machine with maybe Ubuntu pre-installed, and then you would download the binaries from the TigerGraph web page and just use it and install it from there. You could also use the Azure Marketplace image from TigerGraph, which is also available in the marketplace. So that would be one of the options, but there's also another option that I want to show you. So this would be to take the TigerGraph Docker image and run this Docker image on an Azure Machine Learning Compute instance. I will show you in a moment what a compute instance is, but just to make you aware, this could be an option which might be more comfortable. And then on the other hand side, staging and production. Again, you could always just spin up some plain Azure virtual machines, install all the stuff on your own, care about all the firewalls on your own, and so on and so forth. Might make sense in some scenarios, but I would say in most of the scenarios, it does not make sense. It probably makes more sense either to use the managed offering, which is offered by TigerGraph and named TG Cloud IO, or to run TigerGraph on an Azure Kubernetes service. So there's different reasons why you would do one or the other. So you would use the TigerGraph cloud mostly if you want to consume a service which is managed. So if you have no if you just cannot manage the stuff on your own, then TG Cloud would be a good idea to use. However, if there's maybe, for example, there's things you have to clarify first regarding data privacy and where's the data stored and how's it processed, and maybe I've gone already through some compliance checks and so on with your company, then it might be easier to run the stuff on an Azure Kubernetes service, which would be sort of between managed and non-managed. Yeah, just one last word about that slide. So in Azure, we have very large virtual machines. If you need to have a machine which has like 14 terabytes of RAM, that's no problem. You can easily use it. Yeah, if you have a very large data set, yeah, just spin up an Azure virtual machine or use the TigerGraph Docker image or something, and then you can easily load that into our hardware. All right, the next thing is, let's assume you have some TigerGraph database running on Azure. But then I think you're not already done, because in most of the cases you probably also will need some MLOps process. Yeah, so MLOps process is about all the processes that it takes to train a model and then also make the model available to users. So in this case, it starts with training the model, then you would package the model. Once you have packaged it, you probably want to validate it and see if the accuracy and all the other quality metrics are good. And then you might decide that the model is good enough, then you would deploy the model, finally make it available as some web service so that it can be integrated into your applications. And then in most of the cases, you also would like to retrain the model because things change over time, data changes over time, and if the model doesn't fit anymore, then you would probably like to retrain it. So I mean, there's a lot of details now, but I think the message here should be and is that in the Azure Machine Learning service that provides all of these things, so you can use that and really have a managed pipeline which does all the things for you. So you can define different steps in there, and you would not like to have to start up your own virtual machines and so on. When it comes to TigerGraph, there's 2 integration points where you could integrate TigerGraph. So definitely it's a train model stage. So I think a very common pattern and very beneficial pattern is to use data that includes information from relations into your model. So for example, if you wanted to know how about your competitors, how do they work with others and so on, and that's probably something which is relational data. So we could use TigerGraph as an input source for that. But then also on the right side, where you provide a REST web service, and then whenever data comes in, then you would apply some model and then return some estimation. You could also use TigerGraph to derive features on the fly also about the data that comes in, and essentially enrich the model and feed the model with the right data. All right. I will quickly go into some demos and show you how all these things looks like. But just 2 secret hints, I would say. So, for example, if you have an enterprise support contract with Microsoft, then you can also make use of what we call PyTorch Enterprise. And so PyTorch Enterprise gives you enterprise level support for PyTorch. Yeah? So for example, if you have a problem with PyTorch, you need to fix and so on, then you can get this fixed through our support channel, which is already quite mature, I would say. The other tip that I have for you is DeepSpeed AI. So DeepSpeed is an extension for PyTorch, which lets you use your PyTorch model, so you do not have to change any code or something, but essentially it replaces the optimizer and a couple of other things. But once you use that, then we have seen in the past model trainings which were 10 times faster, and we could also run larger models because it's able to distribute things and a couple of other things automatically. So if you haven't taken a look at this, I would definitely recommend that. And that's also something that comes from Microsoft. All right, then let's quickly go into a demo. To switch the screen again. So what you see here is the Azure Machine Learning Studio. That's more or less the place where everything comes together that relates to Azure Machine Learning. And there's a couple of things in there. So on the right side, you see there's the designer. So that would be a tool where you could visually design flows. There's all this auto ML that I spoke about and so on. Unfortunately, we do not have too much time to go through all of these things, but let me show you quickly what a compute instance is. So I will click on compute. And so we have different types of computes that are offered in Azure Machine Learning. So there's the compute instances, and essentially compute instance is like a dev test machine that you can use as a developer and then train your models and do stuff. So I will show you in a moment how this looks like. The big advantage is it's integrated in Azure Machine Learning, so we get a couple of features on top, and then it's also pre-installed, so it's completely different and I would say more comfortable to use than just a plain virtual machine. Then we have compute clusters. Compute cluster would be, as the name says, a cluster. So if you train a pipeline, and there's a step where you would need to train like a very large neural network on a cluster, having several nodes, then you would create a cluster. Then there's inference cluster. Essentially, that's the ability to so if you have trained a model, then you also have to provide this model and operate that model. And inference clusters essentially give you the opportunity to provide that model as a REST web service. But now let's quickly take a look into what a compute instance is. So I've said already, that's a machine for developers. And a couple of things are pre-installed. So let's open JupyterLab as an example. Open it here already. So this is we are installing Jupyter Lab, pre-installing Jupyter Lab on that machine. And if you run the commands that I described in the documentation from TigerGraph, then you can convert the Jupyter Lab that we provide out of the box into TigerGraph machine learning workspace. So just a couple of commands, but if you've done that, then as you can see here already, you can make use of all the tutorials that are provided. You get a kernel which has all the TigerGraph stuff installed and so on and so forth. So I think that's quite useful. Because when you create these compute instances, you can select from different virtual machine sizes. And as I said, we have very large machine sizes. So if you want to run something on a very big graph there, then you could easily spin this up and load the graph into this machine and just run the stuff. All right. So you also have access to the full virtual machine. So let's assume you would have to install your custom packages and additional components and so on. Since you have access to that machine, you can essentially run almost everything here. So yeah, this is an Ubuntu machine, and most of you will probably be familiar with Ubuntu, so you can use this one. But they also have another option how you can use these compute instances, and also how you can use TigerGraph on this. As an example, we also have Docker installed. Yeah, so for example, if you want to run some Docker commands, you can also use Docker on that machine. But I wanted to show you Visual Studio Code and how you can use Visual Studio Code on the compute instance, because there's a few people that really like Visual Studio Code. So let me quickly show you how you can use this one. So what I have here is I've opened Visual Studio Code. And what you can do is you can connect to remote computes using Visual Studio Code. So as an example, if you click on this, well, first of all, you have to install a couple of extensions. So I would recommend when you want to do that, install the Python extension and also install the Azure Machine Learning extension for Visual Studio Code that will give you all these capabilities here already. And yeah, you can then click on this green button. And once you do that, then you're given a couple of options to connect to your compute instance, and that's using SSH. There's also an option available to use WebSockets, but generally I would rather recommend to use the SSH option. Yeah, so once you have that, then you can connect to your to the compute instance that you have created. And then once you have done that, then you can easily run a Jupyter notebook, so also in Visual Studio Code, or you could also take, let me start that. So just let me show you how this looks like. This is just like a simple Jupyter notebook in Visual Studio Code. But if for whatever reason this doesn't really work for you because you are more used to using Python scripts, you could also do the same. Here's a Python script, and then just as an example, select all the code that you want to run, and then you can just click some hotkey, and then it would give you, it would open the Jupyter instance and then run the stuff on the side. So it depends on how you prefer working, but I think that's definitely also interesting to a cup of paper. All right, I think that's it. Let's go to the slides back. Oh no, something that I've missed. What we also have is in Azure Machine Learning. So this is just the compute instances, and that, as I said, would be used for dev test scenarios, but it would not really be used to train productive models. That is because usually you would like to be able to reproduce the stuff that you have done, and you would like to see the code that you have used to train. Probably you would also like to set up a pipeline and so on. So we also have these Azure Machine Learning pipelines, and that's an example that you can see on the screen. So this is a pipeline that has multiple steps, and I've run this a while ago. And what I can do now is, for example, I can click on this train models module, and this will give me now some insight. Actually, I see a lot of Windows overlays here, but this will give me insights into, for example, into the code that has been used. to train the model. So there's a snapshot tab here, and once I click on this, then it will give me exactly the code that I have used to train the model. I can also log metrics when training, during training, so it's similar to TensorBoard as an example. And this, we don't see anything because this run here also has child runs, and it has child runs because there's capability in Azure Machine Learning that lets you find the right hyperparameter. So it's called hyperdrive, and you can give it a couple of parameters and combinations, and then it would automatically try out the model training with your combinations. So it's a little bit more smarter than just doing a grid search. So it's capable of finding out that certain hyperparameter combinations don't work that well. So it would automatically stop the training and then use the compute power for other hyperparameter combinations and so on. So you can see all this, the different trainings runs here. So here's the accuracy plotted. On the other hand side, you can see parallel coordinates charts, and then from those charts you can derive which would be the best hyperparameter combination given the budget that you have, and also given the quality metrics that you have to achieve. So let me quickly also give you an example going into the details. So this would be a child run, and you see when it was started, how long it took to do the training and all the stuff, on which cluster it was running, and so on. And as I said, you can also log metrics. You can log arbitrary metrics with the training. So, for example, I could also take a look at the loss curve, epochs, and so on and so forth. Yeah. Yeah, what you're also working on is, well, actually that's already available, but it's not yet available in this user interface. But we also work heavily on explanations. So if you want to better understand your model, we also have capabilities to that help you better understanding the model and see if your model is fair or if it's unfair, and all of these things. All right, I think that sort of concludes the demo that I have. And now we would go into the Q&A part. And yeah, thank you for attending the session. And yeah, now the mic is open for your questions.
Thank you, everyone.